So in this video I am going to show demonstrate my trained network's performance on the 3D scans that I have. So these are actual surgeons who are holding up the pen and they were scanned. I use these I basically clean these 3D scans to generate the hand meshes that I have for creating dataset using NEDS. Okay, this is another model. This is another model. So I have basically 6 models. There was a CM5, but that was so badly corrupted that couldn't be used. So I have all these models, and last one shows CM7. This one, in this model, the surgeon is wearing gloves. So I'm starting up my dope. Now the network that I'm running right now, it was trained for about 4 or 5 days on hands that look like this. So the models look like this, where the glove was white and there were random blood patterns generated. The lighting and everything was changed. So this is the performance now. This one model. Let me open up CM1. Okay, my computer is acting funny because I'm running a lot of things. Okay, now it's good. Okay. So it's not really surprising that this model cannot detect these hands, because I think this model never saw this colored hand before. It always saw white gloved hands with blood on them, different amount of blood. So it can't really recognize this. Let's try out others. CM2. I'm running dope for my Intel DualSense camera D435i. This one, I think it sometimes tries to detect. You see, because it looks as if like there is blood on the hand. Looks a little bit similar, at least similar to me. So that's model number 2. Sorry, that's CM3. Now going for CM4. So now I'm just going to jump to CM7. So my assumption is that as you can see, the glove is absolutely clean with no blood on it. So this network, which is trained on body hands, I mean the meshes, the 3D models were made in a way that they had random blood pattern on them, so it never can recognize these hands. So that's my assumption, and just to demonstrate that, let me run a network that was trained on datasets which are different than this, which were trained on hands that look like these. That is, there were solid colored glove, there were no blood patterns, they were absolutely clean, and this glove color changed randomly it changed to any color possible, and trained a network, but I used only 10,000 images to train that network. The second network, the bloody hands network, that I trained it for on 60,000 images for 4 days. and the network that I'm going to run now, I trained it on only 10,000 images for just one day, maybe, or 14 hours. So it's not well trained, but you will see a change in the detection pattern. You see immediately, okay, no, sorry, you can't see. Right, immediately the network has catched the hand in here. That is because this particular network, it's used to seeing any colored hands with no blood pattern on them. It's more used to these hands, I think. But of course, the network was just trained on 10,000 images, so I guess not enough pose information was in the data set, and I just trained it for only 14 or 16 hours, so that was not enough to get the model well trained. Okay, I'm going to change to CM6. Okay, changing to CM4. Okay, then changing to CM3. So as you can see, it has started detecting, in spite of the fact that it was trained for a very small amount of time on a very small data set. So that's because the model is now used to seeing different colored hands with no blood pattern in them. Turning on CM2. This should be interesting. There we go. It's very clean scan, and it can detect skin colored hands as well, because the color of the gloves were changed randomly, and it's actually doing a good job actually. Okay, now CM1, the final model. So again, this is the network that I trained the first time. This was trained on solid color gloved hands with no blood texture on them, but this model was trained for very small amount of time. So the conclusion is that I think it would be worth it to train a network on a data set that would be a combination of those bloody hands as well as random colored hands. Uh, so and the image size, the data size has to be very big, so maybe 60,000, maybe 100,000, and it has to be trained for a long time. It took me about 5 days, 4 or 5 days to train my second network, so I'm guessing if I use my own machine it will take me about a week or maybe more to train the model. But yeah, it would be interesting to see the results. Thank you for checking out the video.